passed the exam. And portfolio sets. Okay, so starting today, all lectures are just taken up on the previous material. I mean, sorry, starting today's lecture, all the following lectures will be based on the previous lecture, right? So it is really important to attend every single lecture, because if you just miss one, and like 75% are not missing the first lecture, so it's going to be problematic for the rest of the students. Anyway, we do a different thing now in the course, so we come to a more practical view on synchronization, and what we are doing is called asynchronous programming. So the difference between asynchronous programming and concurrent programming is in that concurrent programming assumes that we have more than one thread that is executing at the same time. And then we use synchronization to sort of prevent deadlocks, to prevent race conditions, so not establish mutual exclusion, all of those properties. Essentially, we just don't want the two threads that operate on the same shared memory to interfere each other. In asynchronous programming, it's a completely different thing, right? First of all, it's not about the fact that we have multiple threads, right? Here we just have one thread of execution. But what happens is that, say, when I have some UI, some user interface, I have some buttons there, and then a user would click the button somewhere, and then this button will do some operation, right? And then the user still wants to be able to navigate the web page, right? So I still want the animations to show. I still want other buttons to be clickable. So I kind of need to separate the user interface that we have on the web from some other tasks that are being done on the business logic. So this is sort of simple, right? You say, okay, you just have two threads, right? So one thread is responsible for the UI, the other thread is responsible for the computation. That's very easy. The problem is that web and JavaScript is a single-threaded environment. So there is no multiple threads, you only have one thread. And then you have to really do some tricks to schedule the operations that are executed in a way that will mimic this very smooth interaction. So you kind of need to do something else to simulate concurrency when you don't have a concurrent environment. And that is what I will be explaining for the next lectures. So we'll start today with an introduction to JavaScript. I do realize that not every one of you is aware, is an expert in JavaScript. You don't have to be. I will explain some of the maybe trickier parts today, and the ones that we actually need to continue with the class. So, as a disclaimer, University of Bergen is a member of the JavaScript committee. I am a member of the JavaScript committee as a representative of the University of Bergen. But I'm here talking today as a lecturer, not as a member of the JavaScript committee. And when I criticize JavaScript, I'm doing it as a lecturer, not as a member of the JavaScript committee, right? Okay, so we start with a very simple examples. So just variable declaration, right? So something like let x is 10. That's how you declare a variable, right? So this is not the only way. You can also declare a constant like this using the constant word, and you can also declare it like that. Who has taken inf214? You know the difference between the let and the var. Anyone wants to? Yeah.
Var is globally.
Not entirely, but you're on the right track. Yeah.
It's about hoisting. So
Yes.
you can use it earlier, but if it's not here, you will get not error.
Yes. So this is about hoisting. So hoisting means like lifting up, right? So if I have a function f here, and then I have here some code like var a is 0. So we would assume that I cannot do anything with the variable a before it has been declared. But in fact, if it is declared as a var, no matter where in the code of the function it is declared, it will be declared immediately in the beginning of the function from the JavaScript perspective. So I can basically write here console log a, right? So even though a is declared syntactically after I use it, if it's declared with a var, it will be hoisted, meaning lifted up to the very beginning of this function. So who knows what will be printed if I run this?
0.
Let's see. So it will be undefined, because at this point it is undefined. But the point here is that it still prints something, but if I do it with a let, which is a normal variable declaration, then I will get a message that I cannot access A before it has been initialized. So essentially what it means is no matter where within the function definition, or within the function body of a function, you have a var, even if it's like super nested in like several if somewhere like very deep inside you have the var, it will be hosted all the way up to the declaration of the function. Right, so what is now suggested, like the best practices, is to always use let to declare a variable. Yep.
Why would you ever need var?
This has to do with compatibility reasons. So originally the design of JavaScript only had var, and then that was the behavior, and then they introduced let. But there is still a lot of JavaScript code that is using var, so they keep var as well. And this is actually a very good question. So the main rule, how the language is evolved, is that never remove anything from the language, because we want to support all the old web pages from the 90s. Right? So basically, do not break the web. Other examples, so something which is called template literals. So let name is maybe ABC, and then I can say let s is hello plus name, right? So, well, you all imagine what it does, just a string concatenation. So what we can do in JavaScript is to use this index with the backticks, and then I can have here a string which is interspliced with code fragments, right? So this is a code fragment here and like that, right? So now this becomes a reference to this variable. And then when I console log s1, I mean, obviously it will be the hello ABC, but that's just the way it works syntactically. So the original design for this was to support domain-specific languages. So you would define a function blah blah something, and then we'll take some parameter here, and then it will do something. And then you wanted to call this function somewhere, and instead of calling it like this, blah blah something, you would actually just use this syntax, right? So you would omit the parentheses, and you will use the backticks. So now if you rename this blah blah to something, sensible, like C++, and then you have something like this, blah blah something, right? So the point here was that this function, for example, would parse this and do something about it, but when you write it as a developer, it looks like that you just say, okay, this is just a piece of code in C++, right? So it makes an impression that it's some kind of special function call. So the reason I'm explaining this is just that you are aware of the syntax. If you see it somewhere, then this is what it means, right? It is pretty rarely used, but sometimes it is used. Any questions? No? Okay. So let me show another example. So let A be 0.
Question?
Yeah.
Regarding the previous function, the parameter of the C++ s.
Yes.
If
It's just this string.
But it comes in a bracket.
In brackets?
Like a
Brackets?
if you in the function node
Yeah.
console log s.
Yes. Yeah. It's an array, but whatever. We will come to that, and that is an infinite ocean of details about JavaScript. Just yeah. JavaScript is like notoriously famous for comparisons. Like, is 0 equal to false, or equal to empty object, or equal to, I don't know, exclamation mark, empty array, stuff like that. I can post a link in Discord. Comparisons are problematic, and this has to do with the fact that it is a dynamically typed language, right? So I could write something like this. 7 as a string multiplied by 4. What will I get as a result?
7, 4, 7.
Oh, I just get 28. Right? So this is very difficult to remember all of these rules on how types are coerced to other types. So here 7 is coerced to a number type. Well, meaning it's kind of implicitly casted to a number type, and then you have 7 multiplied by 4. If you do it like this, I'm actually not sure. Yeah, it's still, yeah. If you do like that, right? 7 plus 4 as strings, obviously you will get 7, 4 as a string.
Yeah,
You see the point, right? So, yeah. Something like 7 plus, no, maybe 10 plus objects, right? Then here 10 as a number is coerced to a string, and then you have string concatenation. I'm just like showing the crazy rules on how this works. Let's try something like this. 1 minus hello world. So what will I get here? Not a number, right? So here, hello world is tried to be casted to a number, and then this is not a number, and then I'm doing an operation on not a number. I get a not a number. Just for fun, is not a number equal to not a number? No, of course not a number is not equal to not a number, because they're different not a numbers, right? Actually, this is the only value which is not equal to itself. You also have some types that represent a nullish value, like you have the null, right? But you also have undefined, which we have seen when we tried to print a variable that was not defined. So if you try to check whether null is equal to undefined, this is equal. If it's equal, it's not, right? So equal is actually object equality, which is stronger than just value equality. And then you have this completely out of this world comparisons, like, is 0 as a string equal to 0 as a number? Obviously it is, right? Is 0 as a string equal to false? Obviously it is, right? Because 0 as a string is converted to 0 as a number, and then 0 as a number is converted to Boolean false, and then false is equal to false. Is it equal? I'm not sure. No, it is not. That's good at least. So then you have interesting syntactic constructs, like I can have let xy equals 1, 2. Right, so I have console log x and console log y, so I can just assign more than one variable at a time. this actually is quite powerful. I could do something like this. xy is yx, right? So I don't need a third variable to swap two variables. I can also do it like that, x plus 1, y plus 1, for example. Right? So, right? So this is sort of powerful. Then I can have function definitions. So just define like that. Square is a lambda function, right? So JavaScript loves now the functional style and lambda functions. So function of x that returns, returns x multiplied by x, and then I can console log square of 4. Right? So let me keep it for a while like that. JSON, so JavaScript object notation. That's the standard for information sharing between anything on the web. So let object, and then the easiest way to define an object is just to define which fields it has, right? So I have field x, which will have value 1, and field y will be an object itself with an a and a field b. And then I can have console log object dot, well, this is the simplest, object dot x will be just 1, object dot y will be this object, and object y dot a will be this. So compare this to Java, where you have to declare all of the all of the interfaces and all what the fields you have, and here you just like whatever I need a field is just whatever here is I just declare it. So that's why JavaScript is so convenient. Well, actually convenient without the quotation marks, because whenever you have some data that is represented in JSON and you get it from somewhere and you just need to modify it, okay, you just add a new field, or you can remove fields and stuff like that. Obviously, this has a price that you don't know the structure of an object. But for that you have TypeScript, right? Which is a typed version of JavaScript, which kind of brings more rigor on the structure of the objects. Another syntactic thing, I can access fields of an object with this dot notation like this, but I can also use array notation. So I can write object x. So this is exactly the same as object.x, right? So now I will get 1. And I can continue here, I can say object y, a, right? So it's the same as this one. And as you can see, I even use the name of the field. I give the name of the field as a string, so I can basically compute the names of the fields. I'll show an example of this in a moment. So let me do it like that, so remove this. So let point be an object with two fields, x and y, and then console log x in point. So this is obviously false because the comparison is not done on the reference to a variable, but on the name of the string. So I could write something like this, and then for this I will get a true. Right, so basically you can check whether some field is a part of an object, and then you refer to the name of the field as a string. A more interesting example here, let data be this 7, 8, 9. Just this. Console log. What happens if I do 8 in data? So now data is an array that has 3 elements, and I say, is element 8 in data? What will I have? well, it's either true or false, right? So what do I have, right? So
I assume true, but I got false.
let's check. I get false.
Why?
Anyone could guess why?
Because it's stored as a string, but we try to check against int.
That's one way to check it, so let's just try to do that. No. What happens if I do, I don't know, if 0 isn't data? True, if 1 isn't data. True, 2 isn't data.
Indexes.
Exactly, this is index, right? So this 3 will be false, right? So this one checks the indices, which actually tells us that now these ones in the objects, they are essentially treated as indices. So 0, 1, 2. So be careful with this in, because it has a different semantics than maybe in other languages that you are used to.
Isn't it strange that they like create a language and they use like human-like language to try to explain something, and the definition of is completely different? Like, why would you use in and then use in?
Well, because the original use case is this one, whether some field is in some object, and then arrays are essentially implemented as objects. So essentially, this is the field number 7 with just no value, field number 8, field name 7, field name 8, field name 9. So an array is essentially an object. So it's just a result of how arrays are implemented in JavaScript.
So you have an array of one element, and you say if 0 is in data, you will always get true.
Yes. Yeah. Because it's the position 0 is always true.
Yeah.
But this is what I'm trying to explain. The in keyword is used to check whether a field is in the object, and then here it makes perfect sense. Whether x is in point, and then arrays are just objects. So in has to behave the same way. Recall orthogonality from inf214. I know that this is not very sort of convenient here. So let me show you another example. So I have like this, and then I have my object, and then here I'll have field 1, which is 100, field 2, which is 200, and then instead of declaring field 3, I could actually compute the name of this field and have something like field plus field number, like that, and then I could console log my object dot field 3. And this works perfectly fine, right? So I can compute the names of the fields. And how do I do if I want to compute it actually here, right? So what I can do this console log my object, and then I can use the square bracket notation. And then here I just say something like field, well, this is the easiest one, right? So just exactly the same as my object of field 3. I can be slightly fancy here and do something like that. Still will be field 3 here, right? So this is very convenient when you get an object from someone, and then you just don't want to like hard code the names of the fields. You want to compute them from some other by some kind of rule. What you can also do, you can you can remove fields from objects. So console log x in object. This will be true, right? And then I just copy paste it. No, sorry. And then here I'll have delete object of x. Right, so I can just remove a field from an object. And then it's not there. Imagine this in Java, right? So just delete, I don't know, person dot name or something like that. It's just another part of it. Let's come back to arrays a little bit more. So let A is an array of 10, 20, 30. And then, obviously, as I already explained, 2 will be an array because it's the index number 2, so I have index number 2. Let's just print this array to see how it is printed. So array is, let's see what we get. Right, so just the values, and then to delete A at position 2. Right, remember arrays are just objects, so I could delete the key with position 2, which is this one, and then I want to print the same, whether 2 is an A, so I kind of should get false, hopefully. Yeah, get false. What happens if I print it now?
Why does it include the comma?
It does include, indeed, so you have this comma here, right? So let's do this, console log a dot length. So somehow the length is still 3. So it removes the value, but it doesn't remove the index, right? So the index is still there, just there is no value at that position, so it doesn't shift the elements, right? It just makes a hole on that position. Because if someone else, if somewhere else in your code you actually use the fact that some other position has some value, then you should still be able to make that assumption. So it doesn't shift the elements after it removes. Yeah.
If you remove the index with the delete, why does the 2 in A still do false?
Oh, that's the behavior. That's how it works. So it gives you false on the inclusion test, but still that position is preserved in the array, but you cannot guess it. You cannot get the value, and it behaves as if there is no value, but in fact there is value. This is not the only thing like that, right? So let's do now. So we can add element 40 and add element 50. And let me print these two lines again. So what is the array and what is the length? So, the length is 1, 2, 3, 4, 5. So that position is still there, and it's just skipped, right? And then I have these two elements that I have added to the array. So when you see something like that, the why question is not applicable, right? So that there is no logic, right? So the language has been evolving through over 30 years, and they never removed anything from the language, right? So you can imagine what happens, right? So at some point they think, okay, this is now the best way to do it, let's do it like that, and then 5 years later they reconsider, okay, this was a mistake, but we cannot do anything with that. Let's just add a new way to do that, and we still keep all of the previous ways to do the thing. Let me show you this for off loop. So let data be 1, 2, 3, 4, 5, and sum will be 0. And then I can do for let element of this data array sum plus equals element, right? So I don't expect any. So don't expect any surprises here, right? So we just get the normal sum of the arrays. So just remember that the for loop here is off. Let me show you another example. So let object be this one, 3 fields, x, y, and z, and then for let element of object console dot log element. And so now I just have to get this problem, because object is not iterable, and already here you see what we will be talking about today and tomorrow, and what we will have in the portfolio set 2. So you kind of see that we need to have some iterability, right? Something can be iterated. So something has values, and you could iterate over that something, getting like a value after value. So I'm going to try this one, and then now interestingly I get the names of the fields and not the values. Right, so that is something interesting. So in really checks the inclusion of the fields, but what we are really interested in something like off, which does iteration over the values, and then that's what I will be explaining in more details later. Something else that you need to know, because it happens in existing code and you just have to understand what it does. So I have this object with two fields x and y, and then I have something like, like dimensions with, say, 100 and 200, and then I want to have a rectangle, and area where it will be 0, and then I want to include everything that the position object has and everything that the dimensions object have, right? So I write the position, dimensions, right? To do something like this, you need to prepend this imported fields with a dot dot dot. Right, so essentially flatten and take all the fields from the position and take all the fields from the dimensions. And then now we go to console log rectangle. Notice that these fields were flattened, right? So I don't have now rectangle dot position dot x. I just have the x directly. Right? You see? Yeah.
Yeah, it's about the previous one with the off, with the border off. Say you want to iterate over an array with off, but before you start the border,
Mm-hmm.
you have deleted one of the indices. Indices. And you count how many times you iterate through the border.
Yeah.
Will it jump over the position that's empty, or
So the interesting thing is that you don't have to count how many iterations you need to do, and that's what I will be explaining, because you convert this array into an iterator that just yields values, and however it is implemented, this is, well, you as a developer actually can override that that behavior, but I'll explain it when we come to that. So here is an important difference, right? So if I have this position and dimensions like this, then they are not flattened, right? I have a sub-object here, position, sub-object here, dimensions. But if I want to flatten it, I just want to take the x and y width and height, I need to take the dot 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 here. And then they will be just, so these fields will just become a part of value. So please don't be surprised when you see in some code this dot dot dot. It is actually pretty often used in JavaScript. So another example, we have an object with field 1, and then I have object p, which is 0, and then everything that the object has, right? So console log p, right? So first of all, let me. So okay, so this is what happens, right? So x here had. So I had a field x here with value 0, and then I have the field x from the object. So it's the same field, so it updates the value. Right? And if I print p.x, I will obviously get the value 1. Let's look what happens here. p.x is 100, and then console. Console log object of x. What happens? Let's see. Yep, So there is now a connection only between this local x that is a part of the object, but there is no connection with the original x in the original object. Right? So if I update it here, it doesn't update it here. Very good, right? That's one of the same parts of the language. Another example here. So Q. Oh no, sorry, it's a continuation. So Q is everything that the object had, and then X is 2. Console log Q of X. And console log Q. Remove these console logs so that we are not distracted. So also works the other way around, right? So if I had something that I take from the object, so this X is 1, and then I introduce a new field, X is 2 after that, then I'll get the values 2 there. So the order in which you declare fields matters. I think I remove this. Let A be this array 5, 4, 3, 2, 1, and then console. And here A dot filter, and then I want to filter it, and this is sort of a idiomatic JavaScript way to do it. So you prefer using functional style. So I have here an array function that, an anonymous function that will only keep the elements which are less than 3. So this is the variable in the lambda expression, and this is the lambda expression itself. So the parameter, this one, and the body of the lambda expression are separated by the this symbol. That's why this sometimes is called an arrow function. So here I will only get the elements which are less than 3. So arrow functions. So constant sum. Okay, so there are several ways to do it. So one of them is this one. So you declare a constant, name it somehow, and then you say, okay, this is now going to be an arrow function. It will take 2 arguments, and it will return x plus y. So now I can do sum of 10 and 20, and I will obviously get 30. And then another way to declare this function, because it only has one expression that it returns, it will be more convenient not to write this return every time, so you just write it like this. So something that takes x and y and returns x plus y. So that's the syntax we used here, so I should have used it like that, with x in parentheses, but because I only have 1, I don't use that. So what you can see in code is that you have something like function f, and then it's like that, right? So if you're not really fluent with this notation, it kind of looks like that f equals to x, then x multiplied by 2. But no. This is f equals to an arrow function that has x as a parameter, and then returns x multiplied by 2. So the example that I have here is this one. Yeah, it's the same, but just write it so that it's this one. Right, so, function p returns the square of its argument. There's also a normal way to declare functions. You just have a function sum and then xy, and then return x plus y. But that's boring, right? So it's just the normal way to do it. What is also quite popular, and I honestly don't understand why, you have this declaration. So if you just have a function that returns always the same value, then instead of just writing this, right, that it's not actually a function, it's just a value, you declare a function that takes no parameters and returns a value. You see it a lot in JavaScript code. It's just idiomatic JavaScript. And I'm not sure whether the word idiomatic should be replaced with another word that also is very similar, but it means something else. So, but you get the point, right? So then, obviously you can return anything from functions. So here's a function g that takes a single parameter, and what I want to return here is an object. So but if I write here a curly brace, then it's a body of the function. So to prevent JavaScript from treating this as a body of the function, I can wrap it in parentheses, and then I can have here an object. So the curly braces I use like for everything, right? For function bodies, for scopes, for objects, for whatever, right? So I can say console log, and we can have g of 5. Right, so it's going to be an object with one field v, and the value will come from the parameter. An interesting use case here is the spread operator. So let numbers be something, and console log, and then I want to do math min of the numbers. Let me just see what we get here. Not the number. So math min expects that we pass here several numbers. So those of you who have taken inf214 would know the word variadic arguments, right? So essentially, I have here multiple parameters, and then if I want to find a minimum of them, I really should pass this not as a single array, but as individual values of that array. So, and to do this here, I need to flatten this array. So I need to remove the numbers from the array and just convert them into individual numbers. How do I do it?
3 dots?
Yes, exactly, dot dot dot, right? So just write dot dot dot, and then this is converted into something more complicated. You can see it works. Yeah. So it would then convert all of these numbers into individual parameters of this function. I'm just explaining this to you so that when you see the code that happens to appear somewhere in either portfolio set 2 or 3, you're not surprised by the dot dot dot. What is dot 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 is about? Let me just maybe take 2-3 more minutes, and then we will go to the break. So now we can get back to this one, right? So square was a function that returns the square of the number. Let me declare it in a more classical way. So function square takes an x and returns x multiplied by x. So obviously I can just call square of 4. But yeah, it's going to be 16, right? What I can also do, I can treat functions as values. Right? So functions are first-class citizens. I can assign functions to variables. I can do whatever with functions. They're just normal values. So what I can do, I can say let s be square. And then instead of this, I can just write s of 4. And then I get the same 16. So now s is an alias, or like a synonym for the function square. I can also do like this. Let object a be some value, and this one will be the function that is the square function. And then I could do console log object.f of 4. Right, so I will also get 16. Let me just check if I have anything else that is relevant here. Yeah, I guess that's it. So after the break, we'll come to parts of JavaScript that are actually relevant for asynchronous programming. Let's continue at 11:11.